All right, guys, today we're going to go ahead and discuss how to simplify a rational expression. Now, a rational expression is just a normal expression that has a fraction, or it's got a top and a bottom, or a numerator and a denominator. First, what you're going to do is you're going to factor both the numerator and the denominator. We're going to try and find things that have terms that are expressed as the same. So x plus 9 and x plus 9, we get to cancel them out as long as there's one on top, one on bottom. And then what's left will be my answer. Remember, you may change an expression such as 5 minus d to d minus 5 by factoring out a negative 1. Remember, terms never actually completely cancel away. There's always an understood 1 left over. So remember, 3 divided by 3 is still 1. It doesn't just disappear and no longer become existing. And then restrictions are what values of x would cause the denominator to be 0, because remember, can you divide by 0 and over O? The answer is no. I'm actually going to move my camera to the other side. Put it up there. Okay, so step number 1 is to factor out both the numerator and the denominator. So my first question I ask myself is there any number in front of my x squared? And if that answer is no, then I can go to 2 sets of parentheses. And since that answer is no for both the top and the denominator, good to go. We're going to have my fraction, 2 sets. 2 sets on top, 2 sets on bottom. So I always ask my question, what multiplies to the first guy of x squared? Gives me x times x. And then what would add to negative 9? I'm sorry, let me try this again. What multiplies to negative 9 adds to negative 8? Well, I've got 9 and 1, and I've got 3 and 3. 3 and 3, no matter which way I try, is going to get me to an 8. So I need a negative 8, so I need a negative 9, so I have x minus 9 and x plus 1. Same idea on the bottom, I have 72. Oh, I forgot my x's, I apologize. Oh, I should do that, not green, not red. Maybe purple. What goes into 72? Well, obviously 1 and 72, but there's no way that's going to get us anywhere remotely correct. We've got 2 and 36. That's not going to work. We've got 3 and 24. Again, not close enough, but we're getting there. 4 and 18. Too close. Ooh, maybe about 9. 9 and 8 go in, don't they? Yeah, I think it's going to give me 9 and 8. Now, I need to multiply to a positive 72, add to a negative 17. So I need both of them to be negative. So minus 9, minus 8. I have a factor of x minus 9 in common. So I'm left with x plus 1 over x minus 8. Now my restrictions, I need to go back to the original denominator. What value of x would cause this first set of parentheses to be 0? Well, something minus 9 would get me to 0, so in that first one, x cannot be 9. In the second one, or essentially what I have here, what minus 8 would give me 0? Well, that would have to be an 8. So those are your 2 restrictions. All right, problem number 2. Again, I asked myself, is there anything in front of my x squared? And the answer is no to both of those. So I get 4 sets of parentheses, 2 on top, 2 on bottom. Starting with the numerator, what multiplies to x squared? X times x. What multiplies to 50 adds to 15. Ooh, let's see, I've got 1 and 50, that's not going to do anything. 2 and 25, and not close enough. 3, 4, 5, and 10. It's going to have to be 5 and 10. And since it's a positive 50 and a positive 15 plus 5 plus 10. Okay, taking a look at the denominator, what multiplies to that x squared again? X and x. Now there's a couple different ways I like to think about this next part. Essentially there's a 0 in the middle. So what multiplies to negative 100 adds to 0? Well, if something adds to 0, that means it has to be the same number, one positive, one negative. And if it's the same number, it's essentially taking the square root of it. So what goes to negative 100? Well, simply 10 and negative 10. Cross out my x minus 10, or my x plus 10s, excuse me. So I have x plus 5 over x minus 10. What would be my restrictions? Well, what would make this guy negative? Or I'm sorry, not negative, I apologize. What would make that guy 0? Well, 10 minus 10 would be 0, so one of my answers is 10. What would make this guy 0? Well, negative 10. So in this case, my restrictions are plus or minus 10. Excuse me. All right, we're going to go ahead and ask myself, is there anything in front of my x squared? That answers no, and that answers no for both the numerator and the denominator, so 2 sets of parentheses on top and bottom. So, we did our 2 sets of parentheses already, but what do you notice about the numerator? If I don't have 3 terms and I don't have a negative in the middle, we actually don't have that 2 sets on top. Most people think, oh, well, it's just always going to work out, 2 sets on top, 2 sets on bottom. But you have to actually pay attention to what's going on. The only thing I could do with the top is I could factor out a term of x into both and be left over with x plus 4. I wouldn't be able to do 2 sets of parentheses because I don't have enough terms, and you're probably saying, well, wait a minute, I didn't have enough terms last time. I technically did. My third term ended up being 0 because I have a squared term and a constant and no linear or a guy with an x. I don't have a constant this time. The 2 sets only works if you have an x squared and a constant, not an x squared and a linear term or something stuck with x. All right, what goes to x squared? X times x. What goes to negative 36 adds to negative 5. Oh, we got 2 and 18, 3 and 12, 4 and 9. Hey, 4 and 9 can get me to 5. So I want a negative 5, so I want a negative 9. Since my answer is a bigger negative, since my answer is negative, the bigger number needed to have the negative sign associated. Cancel out my x plus 4s. X over x minus 9. And what would cause this to be 0? 9 would cause that to be 0. Negative 4 would cause that to be 0. All right, on number 4, if you look, every other term so far I've had my x's come first. So I want to rewrite this problem to start with. So I have negative x plus 2 over x squared minus 4. So I don't have a squared term to start off on the top anyway, so I can't have 2 sets because the only way to get to a squared is x times x. But I never want my x guy to be negative. So I'm going to divide out a negative 1 from the top. And by doing so, it causes my x to turn positive and it causes my 2 to turn negative. On the denominator, 2 sets of parentheses, multiplies to x squared, multiplies to negative 4 adds to 0, plus 2 minus 2. Just realized I keep moving my camera because there's no real good happy spot where I can't find a happy medium where to put it today. It's just all over the place. So you probably missed that because I was talking and because I wrote over my face. Notice how if I take out, I don't want this guy to be negative. Where am I at? Am I showing up on my screen? There you guys, like, where's my mouse? Notice how he has that negative sign associated. I don't want that negative there. I want him to be positive like all the other x's. So I need to take out that negative sign. So then I can cross off my x minus 2's. I'm left with negative 1 on top over x plus 2. See, I don't have a good spot today. X cannot be equal to plus or minus 2. On number 5, I take a look and say, what do I have on the numerator? Well, I see I have x squared and an x, no constant, so that means the most I could take out is an x. Remember, we can rewrite this as negative x plus 6. So I'm going to divide out a negative 1 again and be left with x minus 6. I can cross off my x minus 6's, and I'm left with x divided by negative 1, which is simply equal to negative x. And then my restrictions, x cannot be equal to, well, the only set of parentheses that I have is this one, so x cannot be 6. All right, number 6, we start getting a little bit more complex. I notice I have numbers in front of both of my square terms, but I ask myself, can I divide every single term by the number in front of x squared? So for example, I have a 4. Can I say 4, 4, and 24 all divided by 4? Yes. So if that answer is yes, my first step is to divide it out. So I'm left with x squared minus x minus 6. And then I ask myself, can I do that again on the denominator? I've got 2, 8, and 6. So is everything divisible by 2? Again, that answer ends up being yes. So let's divide it out. Now I'm going to factor the easier forms or the simplified forms versus having to deal with that extra multiplication shoved in there. Now on top, I still have that 4, but I also have 2 sets of parentheses. On the denominator, I still have that 2, also followed by 2 sets of parentheses. The only way to get to x squared is x times x. I want to multiply to negative 6, add to negative 1. So negative 3 and 2. On the denominator, I want to get to x squared again, so x and x. What multiplies to 3 adds to negative 4. Negative 3 and negative 1. X minus 3's cancel out. I can also take this division, 4 divided by 2. Since my answer is 2, it would be 2 on top, x plus 2, over x minus 1. And my restrictions, so x, what would cause this to be 0? Well, I'd get 3. What would cause this to be 0? Well, 1. Oh, they are attached. Okay, we're gonna have to be strategic and creative with this one. So then I ask myself again, can I divide anything out? And I look, nothing can go into 17. 17 is a prime number. So unfortunately, this problem is gonna take a little bit more work. So I'm gonna treat the numerator kind of by itself. I'll treat the denominator kind of by itself, and then I'll put it back together and we'll simplify like we've been doing. So when I have a number in front of my x squared, I have to take that number times the number in the back, which gives me 30. And that's what's going to go on top for my division. So what multiplies to 30 that will add to 17? We're still going to add to that middle number. Well, I've got 2 and 15. I've got 3 and 10. I've got 5 and 6. So which combination is going to get me to 17? that first one. So what I'm going to do is I'm going to rewrite the term, but instead of 17, I'm going to replace the 17 with the two numbers that I found instead. So 3x squared plus 2x plus 15x plus 10. And now we're going to do what's called grouping, factoring by grouping, which means I'm going to group the first two together and divide something out. Then I will group the second two and hopefully come up with something that also comes out to equal the same. So let me show you what that looks like. So the only thing that can come out of 3x squared and 2x is an x. So I'm left with 3x plus 2. And then I'm going to leave a little space and I'm going to get 3x plus 2 again. And I'm going to ask myself, what divided from these two to turn into this? Well, 15 divided by what is 15x divided by 3x is 5, and 10 divided by 2 is 5. So in the little space we'll go 5. So the top part of my parentheses will be, or the numerator, the parentheses for my numerator, will be one of the copied, so the 3x plus 2, and then the outside put together, so the x plus 5. Now I know that was kind of quick, so if you're not sure, go back and watch the video on factoring. We went through all that stuff, promise. Okay, now I gotta tackle the denominator. And if I notice 5, 21, and 20, well 5 and 20 can both be divided by 5, but 21 is not divisible by 5. So that means we have to do the same thing. I'm going to take my 5 times my negative 20, which gives me negative 100. What multiplies to negative 100 adds to 21? Well, I've got 2 and 50, 4 and 25, 10 and 10. Good. Okay, we see we're going to have 4 and 25. So again, I'm going to replace my 21 with my 4 and my 25, but I need a positive 21 and a negative 100, so I need a negative 4. So I have 5x squared plus minus 4, sorry. It's 25x minus 20. So the only thing out of 5x squared and 4x is an x. So 5x minus 4, leave a little space, 5x minus 4. 25 divided by 5 is 5. Negative 20 divided by negative 4 is positive 5. So my denominator now is 5x minus 4 times 5x plus 5. Okay, so let's put those bad guys back together. So we said my numerator was 3x plus 2 over x plus 5 over 5x minus 4 times x plus 5. X plus 5's cancel out, and I am left with 3x plus 2 over 5x minus 4. My restrictions would cause this to be 0. So essentially what I'm doing here, since this is a little bit more complex, is I take my guy, my piece that I set it equal, so I'd add over 4 and then divide by 5. So x cannot be 4 over 5, and x can't be negative 5. All right. I'm going to try and switch some different colors so we don't get too bamboozled on the first problem versus the second problem. I use purple. Let's go with, I guess, the pink. So on the numerator, this one's slightly easier because I don't have two fully factored, or two fully big guys that need the t factoring. I can just do, this is just a undoing of distributing. So all I need to figure out is what can come out of 6 and 21. Okay, well that one's pretty easy. It's a 3. So I can take out a 3 and I'm left with 2x plus 7. The denominator, however, I see 2 and 42, but 5 is not divisible. So we're going to go ahead and have to tackle that with the same idea. So 2 times negative 42 is negative 84. So what goes into negative 84 that adds to negative 5? So I've got 4 and 21. We already have 2 and 42, but there's no way that's going to get me to 5. I've got 6 and 14. Still not going to work. That's not going to work. I'm missing an idea here. 4 and 9. Nope. Hey, there you go. What about 7 and 12? So 7 and 12 can get me to negative 5, so I need a 7 and a negative 12. So I have 2x squared plus 7x minus 12x minus 42. So I can take out an x, I'm left with 2x plus 7. Pretend that says 2x plus 7, I started to run out of room. Oops. And then negative 12 divided by 2 is a negative 6. So I have x minus 6 and 2x plus 7. So let's go ahead and continue working through this problem now that I have the factored form. So I have 3 over 2x plus 7 over x minus 6 times 2x plus 7. I can cancel out the 2x plus 7s, so I'm left with 3 over x minus 6. X cannot be equal to, 6 would cause the denominator to be 0 there, and then negative 7 halves. Ooh. Would be the answer there. All right, I'm going to start problem 9 with you, and then I want you guys to finish it on your own. So my hint is I can start by taking out an x, and I'm left with x squared minus 9. And then I'm going to rewrite the denominator as negative 9x plus 27. So I'm going to pause. You're going to finish. You're going to come back and check your answer, see if we agree. Ready, go. Okay, so you should get x times x plus 3 on the top divided by negative 9. And your restriction is x can't be 3. All right, last one. On top we have our 2 sets of parentheses. Let me make that a little bigger. We have our 2 sets of parentheses because, again, we're adding to 0. I have an x squared and a constant. And then on the denominator, since I don't have a constant, I'm just going to have 1 set of parentheses. So I have x and x plus 1 minus 1. I can take out an x, and I'm left with x minus 1. X minus 1's cancel. I'm left with x plus 1 over x. My only restrictions here are x cannot be 0 and x cannot be 1. Have a good day.